We were right there at the spot, and we've been advancing this field for quite some time. But why the last 2 years? What happened in the last 2 years? Well, 3 things. Chat GPT, of course, started the generative AI era. It's able to not just understand, perceive and understand, it's able to also translate and generation of unique content. I showed you the fusion of generative AI with computer graphics, and it brought computer graphics to life. You guys, just everybody in the world should be using Chat GPT. I know I use it every single morning, used it plenty this morning. And so Chat GPT was the generative AI era. The second, by the way, generative computing versus the way we used to do computing, it's generative AI is a capability of software, but it has profoundly changed how computing is done. Computing used to be retrieval-based, now it's generative. Keep that thought in mind when I talk about certain things, and you'll realize why it is that everything that we do is going to change how computers are architected, how computers are provided, how computers are going to be built out, and what is the meaning of computing altogether. Generative AI, 2023, end of 22, 2023. The next, reasoning AI, 01, and then took off with 03. Reasoning allowed it to reflect, allows it to think to itself, allowed it to plan, break down problems, and decompose a problem it couldn't understand into steps or parts that it could understand. It could ground itself on research. 01 made generative AI trustworthy and grounded on truth. That caused ChatGPT to simply took off. And that was a very, very big moment. The amount of input tokens that was necessary in order to produce and the amount of output tokens it generated in order to reason, the model was a little bit larger. Of course, you could have much larger models. The model 01 was a little bit larger, not much larger, but its input token usage for context and its output token for thinking increased the amount of computation tremendously. Then came Claude Code, the first agentic model. It was able to read files, code, compile it, test it, evaluate it, go back and iterate on it. Claude Code has revolutionized software engineering, as all of you know. 100% of NVIDIA is using a combination of, or oftentimes all 3 of them, Claude Code, Codex, and Cursor, all over NVIDIA. There's not one software engineer today who is not assisted by one or many AI agents helping them code. Claude Code completely revolutionizes the new inflection. And for the first time, you don't ask an AI what, where, when, how. You ask it create, do, build. You ask it to use tools, take your context, read files. It's able to agentically break down a problem, reason about it, reflect on it. It's able to solve problems and actually perform tasks. An AI that was able to perceive became an AI that could generate. An AI that could generate became an AI that could reason. An AI that could reason now became an AI that can actually do work. Very productive work. The amount of computation in the last 2 years, we know that everybody in this room knows the computing demand for NVIDIA GPU is off the charts. Spot pricing is skyrocketing. You couldn't find a GPU if you tried, and yet, in the meantime, we're shipping GPUs out. Incredible amounts of it, and demand just keeps on going up. There's a reason for that. This fundamental inflection. Finally, AI is able to do productive work, and therefore, the inflection point of inference has arrived. AI now has to think. In order to think, it has to inference. AI now has to do. In order to do, it has to inference. AI has to read. In order to do so, it has to inference. It has to reason. It has to inference. Every part of AI, every time it has to think, it has to reason, it has to do, it has to generate tokens, it has to inference. It's way past training now. It's in the field of inference. So the inference inflection has arrived. At the time when the amount of tokens, the amount of compute necessary, increased by roughly 10,000 times. Now, when I combine these two, the fact that since in the last 2 years, the computing demand of the work has gone up by 10,000 times, and the amount of usage has probably gone up by 100 times. People have heard me say, I believe that computing demand has increased by 1 million times in the last 2 years. It is the feeling that we all have. It is the feeling every startup has. It's the feeling that OpenAI has. It's the feeling that Anthropic has. If they could just get more capacity, they could generate more tokens. Their revenues would go up. More people could use it. The more advanced, the smarter the AI could become. We are now at that positive flywheel system. We have reached that moment. The inflection, the inference inflection has arrived. Last year, at this time, I said that where I stood at that moment in time, we saw about $500 billion. We saw $500 billion of very high confidence demand and purchase orders for Blackwell and Rubin through 2026. I said that last year. Now, I don't know if you guys feel the same way, but $500 billion is an enormous amount of revenue. Not one impressed. I know why you're not impressed, because all of you had record years. Well, I'm here to tell you that right now where I stand, a few short months after GTC DC, 1 year after last GTC, right here where I stand, I see through 2027 at least $1 trillion. Now, does it make any sense? And that's what I'm going to spend the rest of the time talking about. In fact, we are going to be short. I am certain computing demand will be much higher than that. And there's a reason for that. So the first thing is, we did a lot of work in the last year. Of course, as you know, 2025 was NVIDIA's year of inference. We wanted to make sure that not only were we good at training and post-training, that we were incredibly good at every single phase of AI, so that the investments that were made, investments made in our infrastructure, could scale out for as long as they would like to use it. And the useful life of NVIDIA's infrastructure would be long, and therefore the cost would be incredibly low. The longer you could use it, the lower the cost. There's no question in my mind. NVIDIA systems are the lowest cost infrastructure you could get for AI infrastructure in the world. And so the first part was, last year was all about AI for inference, and it drove this inflection point. Simultaneously, we were very pleased last year that Anthropic has come to NVIDIA, that MSL, Meta SL, has chosen NVIDIA. And meanwhile, and as a collection, as a group, this represents 1/3 of the world's AI compute, open source models. Open source models have reached near the frontier, and it is literally everywhere. And NVIDIA, as you know, today, we're the only platform in the world today that runs every single domain of AI across every single one of these AI models, in language and biology, in computer graphics, computer vision, in speech, proteins and chemicals, robotics and otherwise, edge or cloud, any language. NVIDIA's architecture is fungible for all of that, and we're incredible for all of that. That allows us to be the lowest cost the highest confidence platform. Because when you're building these systems, as I mentioned, $1 trillion is an enormous amount of infrastructure. You have to have complete confidence that the $1 trillion you're putting down will be utilized, would be performant, would be incredibly cost-effective, and have useful life for as long as you could see. That infrastructure investment you could make on NVIDIA, you could make with complete confidence. We have now proven that. It is the only infrastructure in the world that you could go anywhere in the world and build with complete confidence. You want to put it in any of the clouds, we're delighted by that. You want to put it on-prem, we're happy about that. You want to put it in any country, anywhere, we're delighted to support you. We are now a computing platform that runs all of AI. Now, our business already starting to show that. 60% of our business is hyperscalers, the top 5 hyperscalers. However, even within that top 5 hyperscalers, some of it is internal AI consumption. The internal AI consumption, really important work, like Rexis is moving from recommender systems of tables and collaborative filtering and content filtering, it's moving towards deep learning and large language models. Search, moving to deep learning, large language models. Almost all of these different hyperscale workloads are now moving, shifting towards a workload that NVIDIA GPUs are incredibly good at. But on top of that, because we work with every AI lab, because we work with every AI, we accelerate every AI model, and because we have a large ecosystem of AI natives that we work with that we can bring to the clouds, that investment, no matter how large, no matter how quick, that compute will be consumed. And that represents 60% of our business. The other 40% is just everywhere. Regional clouds, sovereign clouds, enterprise, industrial, robotics, edge, big systems, supercomputing systems, small servers, enterprise servers. The number of systems, incredible. The diversity of AI is also its resilience. The span of reach of AI is its resilience. There is no question this is not a one-app technology. This is now fundamental. This is absolutely a new computing platform shift. Well, our job is to continue to advance the technology, and one of the most important things that I mentioned last year was our year of inference. We dedicated everything. We took a giant chance and reinvented while Hopper was at its prime and it was just cooking. We decided that the Hopper architecture, the NVLink by 8, had to be taken to the next level. We completely re-architected the system, disaggregated the computing system altogether, and created NVLink 72. The way that it's built, the way it's manufactured, the way it's programmed completely changed. Grace Blackwell NVLink 72 was a giant bet, and it wasn't easy for anybody. And many of my partners here in the room, I want to thank all of you for the hard work that you guys did. Thank you. NVLink 72, NVFP4, not just FP4 precision. FP4 is a whole different type of tensor core and computational unit. We've demonstrated now that we can inference NVFP4 without loss of precision, but gigantic boost in performance and energy efficiency. We've also been able to use NVFP4 for training. So NVLink 72, NVFP4, the invention of Dynamo, TensorRT LLM, a whole bunch of new algorithms. We even built a supercomputer to help us optimize kernels and help us optimize our complete stack. We call it DGX Cloud. We invested billions of dollars of supercomputing capability, help us create the kernels, the software that made inference possible. Well, the results all came together, and people used to tell me, but Jensen, inference is so easy. Inference is the ultimate hard. Inference is ultimate hard. It is also ultimate important because it drives your revenues. And so this is the outcome. This is from semi-analysis. This is the largest, most comprehensive sweep of AI inference that has ever been done. And what you see here on the left, on this side, On this side is tokens per watt. Tokens per watt is important because every data center, every single factory, by definition, is power constrained. A 1 gigawatt factory will never become 2. It's physically constrained. The laws of atoms, the laws of physicality. And so that 1 gigawatt of data center, you want to drive the maximum number of tokens, which is the production, the product of that factory. So you want to be on top of that curve as high as you want. The x-axis is the interactivity, the speed of inference, the speed of each inference. The faster you can inference, the faster you could, of course, respond. But very importantly, the faster you can inference, the larger the models, the more context you could process, the more tokens you can think through. This axis is the same as smartness of the AI. And so this is the throughput of the AI. This is the smartness of the AI. Notice, the smarter the AI, the lower your throughput. Makes sense. You're thinking longer. Okay? And so this axis is the speed, and I'm going to come back to this. This is important. This is where I torture all of you. But it's too important. Every CEO in the world, you watch, every CEO in the world will study their business from now on in the way I'm about to describe. Because this is your token factory. This is your AI factory. This is your revenues. There's no question about that going forward. And so this is the throughput. This is the intelligence. Better perf per watt for a given power of data center, the more throughput, the more tokens you could produce. On this side is cost. Notice, NVIDIA is the highest performance in the world. Nobody would be surprised by that. They would be surprised by the fact that in one generation, whereas Moore's law would have given us, through transistors, 50%, 2 times, Moore's law would probably give us 1.5 times more performance. You would have expected from Hopper H200, 1.5 times higher. Nobody would have expected 35 times higher. I said last year at this time that NVIDIA's Grace Blackwell NVLink 72 was 35